Okay, alright, so this is What the Hackathon featuring microwaves. Um, Today it's 24th of August 2023, 7:36 IST. I'm at Nicer, Bhubaneswar. What's the Bhubaneswar? More precisely, I'm in Yamuna 401. This number fits so good, 401. Nice. And yeah, so I've been postponing this discussion on modulation of microwaves and stuff. It's been pretty late already, but let me get to this. Let me get to the crux of these things. So here's the premise. We have a transmitter. That emits supposedly microwaves. Well, it does emit microwaves with the clustron on top of it. And yeah, you technically get a 9.4 gigahertz signal that you'll not be able to read because your diode is not so capable of reading such high frequencies. That's one thing, but the other thing is that the provided oscilloscope is also dumb. It can only read up to 70 megahertz. So yeah, so supposedly both the diode and oscillation is dumb and it cannot read 9.4 gigahertz signal. What we do is we modulate it to a 50 hertz signal, 50 kilohertz signal. So there are two things here. One, the usual modulation. What do people do? You have a message signal, maybe an audio signal or maybe a digital information that you code it into your messaging signal. In your messaging signal, you have some information that looks like this, and now you want a now you use microwaves to modulate this and get something like this. Something like that, I guess. Yeah, that's the thing. So that's how usual modulation works. Now you read the same frequency. I mean, the frequency is constant-ish thing. I mean, things are a bit vague here. Okay, let me. Yeah. Okay. What I'm telling is, you have two ways of doing things. One is this. This seems legit. The second thing could be, if you just think at the first sight that first thoughts or side whatever that diode has a problem of not detecting 9.45 gigahertz signal, right? What you want to measure is actually 9.45 gigahertz signal, and the diode is not able to measure that. If the diode is not able to measure that, then what you do, you modulate into it into something else. You see, you're modulating microwaves into something else like a 50 kilohertz signal. Then in this terms of thoughts, what you write is messaging signal is rather your microwave, and then your carrier signal is this. That's fucking no way possible. So just scrap it out for now. Let's scrap it out for now. We know the equation for this. If this is not working, and then we'll go to the other thing, okay? Because this is what makes sense. You use microwaves to modulate a messaging signal. Now, how do you do that? I mean, you want your waveform, the output waveform, to have the characteristics of your microwaves, not the other way around. You don't want your output characteristic to be the characteristic of the messaging signal. So how exactly the modulation is occurring is still in a black box. That's why we need to connect the external modulation and check for ourselves that how amplitude can you decide it. Maybe I don't know. See, point is microwaves ka, I mean, the freeway setup, the freeway black box of modulation and output may have the stuff. Okay, it might have the information of what it is producing, obviously, except that they are not on the internet anymore. But yeah, so that's the thing. The messaging signal, the microwaves. Now I could basically, yeah, that's the thing. I want to start writing equations and check for how the patterns are coming and stuff, but the problem here is this picture is the other way around. I mean, this picture has a problem. Has a problem that exactly. I think I did a mistake here. I think I made a mistake here. My messaging signal is not this. Definitely, I'm not this. Not this. Okay, so your messaging signal is actually a 50 kilohertz. That's what you want to read, but you want to modulate your messaging signal into an amplitude that you can read. Okay, let's try that. So usually equations read that if your message now things get shady because both space and time readings and okay, so but we won't matter, right? MFX is just constant in time, so I mean, yeah, it's partial. Okay, whatever. So m of xt is actually your messaging signal, which is a black box amplitude you don't know. It's something like a cos 2 pi omega t. Okay, no, cos omega t, you know that it corresponds to 2 pi of 50 kilohertz frequency. Well, what do you write? Omega mt, you write, yeah. So basically omega m is equals to 2 pi into fm. Fm is here 50 kilohertz. Okay, so that's fine. So okay, that's fine. Now you have a carrier signal. Carrier signal is your big boy microwaves, whose amplitude is also in the black box. It's a0. Now these things are interesting. Now, well, let's just write ax, right? Ax cos omega omega ct. Now omega c is 2 pi fc. Fc is your 9.45 gigahertz signal. 9.45 gigahertz signal, and that means I don't know what happened. Okay, so what do we call the output wave? Come on, diode. D of x comma t is, as the amplitude modulation theory gives us, it is 1 plus m of t by, I mean, come on, it's just t for us. I'm just writing m of x t for my sanity or something. And a, what is a? C, carrier t. Okay, it's a of x. Okay, interestingly, m is not a function of time. M is not a function of space. Come on, right? M is not a function of space. So cool. That's fine. This is not fine. This is m of t. Now times, oh fucking, now this is so messed up. This is messed up. This is so fucking messed up. A of x in the denominator straight up puts r in the numerator and it increases with space. Now that sucks. That clearly sucks. So it's no way this is true. But I'll proceed with the calculation for now. Of t, carrier signal is a of x. Oh, that's fine. That's fine. That's fine, bro. That's fine. That's really fine. It still has that feature of decreasing nature. So obviously I need to put back things now, and I'll plot it. Of course it's a bit shady, and it's cos omega mt by, oh my god, okay, so it's a cos kx. Cos kx, I will write kcx just for sanity. Cos kcx cos omega t times r, okay, x, we are in 1d, lowly 1d, a by x cos omega ct bracket. Now that if you just put the dependence aside, 1 by x b naught cos omega mt by a cos kcx, and then cos omega ct. Okay, that is still problematic, and okay, things are at the level of sinusoidal modulation. I mean, yeah, things are at the level of sinusoidal modulation. So okay, so that's still bad. If you put a constant time, constant x in it, what do you get? You get like, okay, I need to plot this, of course. Analytically, what do you think is, if you put x as constant here, it should be of cos wave, but no, it actually has some shit inside also that depends on time. So yeah, so so you get a shit, like you get shit out and stuff. Okay, all right. Okay, all right. Obviously I'm going to plot it, but of course my mind first thinks it analytically what happens, and you know. Okay, I'll just put these as parameters that I will feed in. So what do we have here? Omega m was 2 pi times 50 kilohertz, right? What do we have omega c as? Kc as, acha, Kc is interesting. Kc is 2 pi over lambda. 2 pi over lambda, you say just 3.2, yeah. For now you just say 2.2, and x is in centimeters, let's say. Okay, 3.2 कर देते हैं. 2 pi by 3.2 was around by 3.2 is around 1.96. So Kc is around 9. Yeah, Kc is this, is around 1.96 centimeter inverse. Bear that. This is second inverse, and 2 pi times 9.45 into 10 power giga is like 10 power 9, right? Kilo, mega, giga. Of course, I'll just check it. Yep, it is 9 billion bytes. Omega is a million bytes. Okay, 10 power 9 second inverse. So what do we choose here? The ratio is around, you see, the ratio is around 189, right? Yeah, that's what really 50 times 189 into 1000, it's like divided by 10 power 9, it's like 9.45. No. See, it's clearly something I'm 9.45 into 10 power 9 by 50 times 10 power 3 is around 189,000. So your ratio is around 199,000, maybe 189-ish thing. I don't know. Okay, let's control this. Okay, so for now, let's put messaging signal as low frequency. Let's say 2 pi. Okay, basically, you're not interested in time domain thing at a we'll fix t. Right, we'll fix t and at with varying x, so how it is. So yeah, that's fine. Okay, yeah. Yep, all right. Okay, good. So 2 pi times, I don't know, yeah, put some 1. Let's put it 1. 2 pi times maybe 189, or if not 189,000 or whatever. Okay, I mean, let's just see here things. Okay, and then okay, that's the problem with theories, right? You try to figure out everything by theory first, and then you go. Sometimes you just have to go blind. Okay, I mean, it's the moment of truth. If this doesn't work, I don't know what will, right? So let's just move this, start with a newer thing. So you have 1, okay, we're gonna have a bracket 1 by x plus 1 by x plus b cos omega t. Okay, well, let's write empty. It's a message thing. By it's a cos ct. kt is better. And then cos, it's ct. It's ct now. Fair job. Why is it not showing up? Okay, something wrong with the brackets. Brackets are not syntactically right, I suppose, and all. Okay, m is what? M is 2 pi. Alright, 2 pi into 189 . Alright, not everything is kt. This is kx, and this graph looks insanely bad. I mean, I wish I could show you. I mean, I can show you. That's nice. That's the good part. Okay, that's bad. I don't know if that works, but this is the fucking graph till now. But yeah, I don't want that recording. I hope the recording is on. Fair enough. Okay, I need to go to breakfast, but yeah, that important thing is I don't have a class at 8:30 today. Hopefully I don't have a class. Okay, I don't have a class. Nice. Okay, now it's cos ct. What's problem now? What's problematic? Why is t is being plotted? I didn't even put anything with t. How can you even take that? I mean, what do you think t is? I'll put b. I'll put a. All. Okay, a is actually b, so I'll just put a. So add slider for a. I don't want slider for b. I mean, things are really shitty. I mean, 1 by x. What are we seeing here? With space, we want it to decrease. It's not. So this modulation is not okay. Okay, add to that slider for B and A. How come it just assumes anything, huh? Oh, oh, oh. B के लिए ऐड करूँगा. B is equals to A लगा करते हैं यार. come on. कुछ भी लगा लो भाई. क्या है यार ये निकाल दो. K डाला ना ऊपर. K is 1.96. Oh. But this still sucks. Okay, this still sucks. Wait, is there a chance of it oscillates? Wow, I mean 1/x, yeah, near 0 it goes up, come on. But, this is so bad. This is so bad. I should show you, I don't know whether it's been showed or not. Let me just stream that also. Okay, that's what I see now. Problem with this is okay, what do I want a spatial dependence on things, so I want a graph as a function of space. Okay, I got something, but at constant time, I mean I'm changing the time. Of course it goes to 0 also in time, but I mean I could vary the t parameter or a parameter, that is. Doesn't seem to do anything good. Obviously it won't be negative, but this whole nature of this graph is weird. Yeah, right. I mean, let's just assume that t is 0. It shouldn't depend on time, right? It is a, yeah, I mean, sorry, let's just remove time for now. Oh, COS KX नीचे है. That's bad. That's really bad. That's where things are going crazy. COS KX is in the denominator. Oh fuck. No, that's bad. That's certainly bad. It's back to talk. COS KX, what the fuck I was expecting? I mean, COS KX denominator में होगा तो क्या ही आएगा भाई? Shit. So that's bad. Okay. That's certainly bad. Okay, now to the. Okay, why is it bad? It's a black box. Come on, it's still a black box. You're not. I mean, yeah. When you play around with the theory a little bit, and then you can actually use external modulation and figure out stuff. So, okay, that's fine. That's fine. Now, let's go to 2. Let's go to 2 and check. Check if our message is actually. Which sounds sane actually. M of x, message signal is our black box amplitude microwave coming out of freaking klystron cos omega ct omega mt. Now note that m is 2 pi fm. Fm is actually 9.45 gigahertz. Okay, then okay, carrier signal. Carrier is in time, black box amplitude. Do you think the amplitude is changing? No. Chichi. भाई इसलिए एक्सटर्नल एम्पलीट्यूड लगा के देखा यार. बट हाँ, cos omega ct, omega c is it's a lowly 50 kilohertz but highly LA. It's a good frequency for the diode and oscilloscope. Okay, so the signal is now y of xt, okay, that's more stuff, is 1 plus a of x cos omega mt by b cos omega ct. Now that is also a problem. Cos नीचे आ रहा तो that's true. The carrier signal was last time it's a of x, and I was clean with my notation and things followed right. Now it's actually b, which is very very sanely looking. It is very sanely looking, and times c of t. Did I multiply the right term, carrier term? Yeah, I did do that. Yeah, now times carrier. What is carrier signal? Carrier signal is b cos omega ct. All right. Fair enough. Okay. It's very simple now. It's a by b x cos omega mt b cos omega ct. Okay, things are really still bad because I've already done this. So it's 1 plus a by bx. I think I should just create a new. Let's just create a new. Relax. New blank graph. Paste. 2 pi. Cancel. Wait. Okay, this is bad. 1.96. Cos 2 pi 1.96 actually. 1.96x, and there is no 2 pi. It is actually 2.1. The messaging signal is high frequency one. It's 189 times that. Well, 189 times 1000 times that. But let's just stick with that. Okay, and then cos 2 pi x. Not cos 2 pi x, buddy. It's time. It's in time that I fucking messed up. It's 2 pi t. So I should see something here. Obviously, y equals, but I don't see something here. It's hey, let me just put a. Okay, t is fine. What's the error? Cannot access a coordinate of a number. What do you mean? I mean, what? What do you mean? A equals, B equals, t equals, what's the problem? Okay, buddy, come down. 1 plus. Oh, just show it to you. Show it to the folks. So that's thing. That's the thing. Okay, not possible to show. Do some jugaad, of course. Come on, yeah, jugaad. Bottle. Yep. That's fine. That should do something. Yeah, it should more or less show the plot. Okay, so okay, 1 plus the equation I had is, okay, now I can't see the equation, but okay, it's fine. Cos of 2 pi, it was 189 times t, of course it's all, and divided by x into b, which I'm also going to add a slider for, times, okay, do we have two things on top? We have two things on top. Cos omega t, oh yeah, where did I mess up where did I take the cos of, okay, I really messed up this. It also reads cos of kx, right? That is important thing. A of cos of kx. K is usual 1.96 centimeter. So 2 pi by 3.2 approximately, dude. Okay. Just going to plot it as an equation and then I'll show you what happened. So A cos of 2 pi 189t. 189t, that's fine. No silly things. Cos of 1.96 times x. Interesting curve, but not so interesting, behold, because cos of, there's another term called cos of d of cos of 2 pi t, 2 pi and t. Oh my god, this is interesting. I mean, this is the thing we got yesterday. Yeah, this is the thing we got yesterday. It's actually cool. Yeah, it's actually cool. Just vary t if you just, yup, exactly. Negative it won't show, but it is going to 0 still. Okay, why is it even negative? Okay. Oh man. Okay, why don't we just put it x, put it, why don't we just change t and x? So, t and x. Okay, that's really shady. I don't know what I'm doing. Exactly, but now okay, obviously this is just 0. This is space basically, okay? This is space. Let's start from 0. Let's go till like 100 centimeters. Let's go slowly. But things are not apparent. Yeah, not so apparent. Okay, let's start again. That's really, it's really fast to see anything. Can I go slow? Perfect. Oh fuck, I haven't showed you anything. This is good. This is actually what we are thinking. Okay, the fact that it goes to negative is not is bad. I guess. Does it go to negative? It blows up at t equals to 0. Yeah, obviously. I mean, let's start from 1 then. It doesn't kill. Doesn't hurt. Bruh, this is exactly what we are seeing. Obviously, it doesn't go to 0. Exactly. Oh fucking god. So finally it is modulation that solves everything, huh? Fair enough. Okay, that's it for now. So I have to fly him about this and tell him that things are looking good. Things are actually looking good. These what the hackathon series are too good. So the conclusion is that your messaging signal is actually your microwave, and you're modulating it as sanely as it sounds with a 50 kilohertz signal, and you're getting a nice little thing. That's exactly it. Now it's just that instead of sine wave, you have a square wave. Things are same. Okay, obviously I want to plot this amplitude with respect to time, with respect to x. Now what do I do? Like, this is actually a space part, right? So what I do is again replace, go back to the x in time and stuff. This is t, bro. Okay, this is what we're seeing more or less. I mean, maybe I'm not there, but we started from here and just drops and drops and. I mean, okay, let's squeeze things out. Okay, x-axis मुझे 0 से ही चाहिए बस, 0 से भी नहीं चाहिए मुझे. Let's just say 2 से लेंगे, नहीं 1 से लेंगे. ओके भाई 1 से लेंगे, ठीक है 1 से लेंगे, ओके 0 से ले लेंगे, ठीक है. स्टेप ना, let's say 0.5 mm. Start with 0, start with step 5, and you want up to 100 centimeters. Okay, or we took up to 20 centimeters, so let's just put 20. Y-axis को zoom out करते हैं ना. We want only till 2. Let's just say we only want till 2, and let's say we want up to step 0.1, 0.01. I don't want to see anything negative, so that's 0. Okay, the offset thing, we don't see the offset. It's not oscillating around the offset. That is a problem still. That is a problem. I'll just show you the graph. But that is a problem. Reverse contrast. Okay, that's fine. Braille mode. Okay, no more. This just looks cool for the electronic circuitry thing. Of course, but it's day here, and I'm really messing with things. Okay, and minor baselines, I want those. Axis members, I don't want those. Arrows, I don't want those. Obviously we want these, but the problem with this graph, we saw up to 20, right? If you just okay, I have the thing. me just show you. Let me just show you something. Okay, that's bad. Okay, that's bad, but so Mr. 7 microwaves. Just open microwaves and see 6 and shit. Okay, you see this thing? We took around 20 centimeters. We don't see an offset. We just see a decrease, plain decrease. 20 centimeters, 0.5 meters for everyone. The analytical graph is rather it is rather bugging. Although it is, we have theoretically gotten there, but something is bad. Do you think it's a? Do you think it reads the intensity? No. I mean, if you just put a by x square, I mean, yeah, still, you see, point is, if at the point is there's an offset. That's the thing. It oscillates around the offset. Even if x goes to infinity, you see, it doesn't go to 0. It goes to 1. It oscillates around 1. Or whatever the b is, right? Okay. What if b would reduce b a lot? I mean, obviously all are positive, man. This is just shifting now. This is bad. What about this? Yeah, it's fairly straightforward things, but why do you see a decrease? Is it because of the interaction with the atmosphere, the air? I mean, it might be, but yeah, I guess yes. Because obviously any wave, if you just put it, obviously doesn't go straight now. It gets dampened, and I guess this whatever carrier signal passing, this is not passing through a circuit. This is passing through air, right? And it interacts with the air, I suppose. I mean, humidity, air out, and everything has a scene in the World War II era reports and stuff, but. Yeah, more or less this is the analytical form of things, and we've actually obtained a curve. Fairly good, but the damping must be explained. We're probably there. Okay, alright. Okay, so that was that, and this is rip my screen. I have to clean it. Okay. I mean, the black, of course, it reflects things. So let's go back and I want this. Okay, so the hackathon concludes now with a good insight that we have theoretically we have obtained this curve. I mean, what was in this theory, it's just straightforward modulation, but things are good when you figure things out. Yep. Okay, so what's next? The damping is not explained. Damping is not explained. That is a problem. My theory is for that interaction, obviously interaction with air and stuff. Obviously a signal doesn't sustain as it is in a non-vacuum medium. Obviously this is not a medium, this is not a vacuum, so obviously things will interact and fall off. Interact and fall off. Okay, and how does that happen? Is there a theory in that in air this amount of temperature, this amount of humidity, things go this way and stuff? Or this is our first reading? Obviously it's not. It's people, and again in World War II era, people have done things and stuff, and I will go have a breakfast now and